Hey, what's up everybody? This is Titans of CNC, and I'm here with my quality manager, Travis, and I'm here with Stuart, my top mill machinist, making it happen every day. So as a shop owner, whenever I get a print from an aerospace company, I actually meet with my guys and we actually evaluate the job, we evaluate the specs. At the time of quotation, it's important that we understand the process. So I want to make sure that my quality manager has actually signed off on this print, that he has brought to light certain aspects of the job that will be difficult to hit or impossible, right? I don't want to quote something that I can't do. Therefore, I lean on him. In the same way, we want to look at the process. We want to look at the machining. We want to look at the quantities that we're going to be running and actually look at the duration of this project. Meaning, is it just a one-time deal, or are we going to have multiple releases, maybe spanning out years, right? Because the thought process changes. And therefore, I want to talk to Stuart, who actually is going to be the lead on this job. Are we going to set up every single time that we run the job, or are we going to develop fixturing in a way that we can duplicate the process quickly and efficiently and take most of the setup out so that on the second time we run it, the third time we run it, we're able to bring the cost down to actually charge just for runtime because there's no setup. Therefore, you just systematically go through the process, make the parts, ship the parts, boom, go on to the next job. So let's actually talk about this job right here. And I'm excited because this is the Titan 513M. It is an aerospace ISO grid. Companies all over the world in the aerospace field, they actually make these ISO grids. All shapes and sizes and different types of materials, but they're all basically the same. You're taking 80 to 90% of all the material and you're roughing it out. But during that process, of course, if you're taking all the material out, it's going to want a potato chip on you, right? And therein lies the importance of what we're going to teach you right now. We're going to teach you the exact process to machine perfect ISO grids. So this particular job is coming from an aerospace company. We're running about 20 pieces per run. So when talking to the buyer and the engineers for this project, they let me know that the production of this job, although the quantity is low, it's going to run every few months for a long duration. So I want to look at the tolerances, and then I want to look at the setup, and we need to create a setup that allows us to reset the job up efficiently in a short amount of time. So first, let's speak to the tolerances and to the print. So Travis, compared to some of the jobs that we do, the tolerances aren't that tight, right? But because it's aluminum, because you have the bow factor, you got the true positioning coming off the datums, it actually needs to be taken pretty seriously, right?
Yeah, no, absolutely. I mean, this is an aerospace part with aerospace GD&T and tolerances on it. And you're going to want to think about not only how the part begins, but how the part ends. And it's my job to make sure the part ends well. So it's definitely something throughout the process. You want to make sure that every tolerance on here is something that you have as a machinist in the back of your mind.
Absolutely. And for those that are learning aerospace terminology and how to read aerospace prints, this is actually great right here, because this print, when you learn to understand it, you'll be able to read other prints from top aerospace companies. So as is standard in the industry, you have all your notes, you have all your dimensions, your GD&T, everything specified. And through the process of making this part, Travis is actually going to show you how to inspect the part and the importance of each and every call out all the way through the process until complete. All right. Another thing that I'll say about these prints is the first 4 prints, it's everything about the part. But when you get to sheet 5, it's actually an in-house engineering print that we actually give you. And sheet 5 shows the orientation of the part and how it sits on the raw material. So that's an added value to help you understand this process. So on sheet 6, we're taking the raw stock, we're putting tooling holes into that material, and we will explain the process. What's really cool is we actually give you the tooling holes dimensioned with the part, again, orientated correctly so you can clearly see it. Once the tooling holes are in, then this particular part will actually go over a fixture and drop down perfectly. So then the final print is actually the fixture and how the part sits in the fixture with the ID expansion clamps. So Stuart and I talked and we came up with a great process for this part. Most of the job is going to be machined on the DMG Mori DMU on the 5-axis. We're going to pretty much machine everything complete, but we're going to have a pre-op. And on the pre-op, we're actually going to put it on a Haas because we have a VF6 with a nice wide table, which will allow us to just clamp the material in its raw state, making the part perfectly flat with tooling holes. Then we're going to inspect it, and then we're going to take it to the DMU, and we're going to make a crazy fixture, right?
Yep. This fixture, we want it to be very easy to work with. We want it to load in first try. We want to be able to accurately pick up the same positions that we left off in terms of when we first ran our program. This will help the repeatability of the job and get us to set up with almost zero runtime, so that way we could go and quickly make the parts as much as possible. So we are going to actually use the Schunk Vero S clamping pallet system. This is a great system for any 5th axis machine. And since it's pneumatically actuated, there's actually nothing that will bind or hold down the table. So that way we have a perfect free range of motion, which is super important to any 5th axis job.
So now we're getting ready to run the prototype. We're gonna make sure that everything's perfect. We're gonna teach you each operation, what we're doing. We're gonna teach you the inspection. We're gonna teach you how we built the fixture plate. This is the start of the 513M, the ISO grid. See you guys later.